Okay, let's share our advent of code with a few people. And let's also bring this to Discord there and there. Okay. Right, let me just make sure that I open the stream on the second screen because last time there were people in chat and I wasn't able to see them in YouTube Studio, so that was very annoying. So apparently people were talking during the chat, but I couldn't see any of it, so that was really, yeah, it was unfortunate. So I wasn't ignoring you guys, I just literally couldn't see the chat happening. Okay, so yesterday, this was for the screenshot of today. As you can see, I'm still at 28 stars. I still need to do day 15. So yesterday we coded up a solution that worked for the test input, but wasn't fast enough for the real thing. And during the stream, I was like, okay, I wrote a recursive function, but my pathfinding isn't up to snuff there. It's not fast enough because it would check too many options. And I found a path with 666 entries. Hey, Luke, glad to have you. At least now it shows up in YouTube Studio as well. So glad to have you here. So yeah, yesterday basically wrote working code, but it wasn't fast enough for the big test. So during the stream, hey Smabook, welcome as well. Glad to see you. So sorry for not engaging with you guys yesterday. I really couldn't see any chat in YouTube Studio. So I opened up a second monitor to make sure that I don't miss anything today. So yeah, yesterday we couldn't finish it. And while searching, I was like, okay, I probably need to implement Dijkstra, which I haven't done before. So I looked that up during the stream, but it was just too much and I was already tired. So this morning I went and did a find path Dijkstra function. One thing that I found was that the important part to implement Dijkstra was the priority queue. Making sure that what it is basically is to make sure that you have all your options, and what you want to do is you want to try the one that's the least expensive, right? So let's see, not sure you could see the chat yesterday. We were trying to make suggestions. Yeah, I'm really sorry. After the video I was like, oh my god, let me go back and see what they said, but I couldn't even see that because the video didn't have the chat there. So yeah, I'm really sorry. Let's hope today is better. So yeah, let me see. I was explaining Dijkstra. What it basically does is, besides the visited, you also want to track how expensive they were. You keep a queue of all the possible paths, so you start here and then you go, okay, this one was 0, 0, this one was cost 1, this one is cost 1. So then you take the first one with the lowest priority. From there, if you go down, you have 2 and 3. So from there you go to 2. And then you end up with 3. And now it's equal to, like when you go here, then it's equal with going this way as well. And so it will always take to 1. Yeah, I know. He's saying there's a priority queue in .NET now, in .NET 7, but the project that I'm writing is .NET Core 3.1. So I looked at that. I actually looked at that, and I don't have the new Visual Studio installed yet. So this one is still .NET 3.1. I know there's a priority queue class in .NET. But what I did was I looked at NuGet. Let's see, manage NuGet packages. And I found this project, the optimized priority queue. There are 2 levels, a simple and a more hardcore one. I wasn't ready to do that because that was fairly involved. The simple one does just fine, I think. So there were a few. I could find stuff about this one. So yeah, I actually even thought about going into the .NET 6 source and porting the priority queue to to Core 3.1, but I'm not sure if that's a good use of my time. It would be cool to learn more about that because it's a data structure that I rarely use. So for those who don't know, a priority queue is basically like a list, but the ordering is based on this second value. So let me see, when you enqueue it, you have your value that you put in there, and then you have a priority. And what it does is that it sorts, or it keeps an ordered list based on this priority. So when you dequeue, it will always pop out the one with the lowest priority. And that is basically the Dijkstra. I think this one. Yeah, this one has a like a visualization here that you can see. Let me move it to the left. Basically what you can see is that it just, for all that is in queue, and the blue ones are actually the things that are in the queue, it will just keep trying the one with the lowest cost that it's known so far. So what you know is that at any point that you arrive, you got there the cheapest way, because it will always take the cheapest path first. And that's basically what it does. So I have not submitted it yet, but I think it will be okay. So basically I had my find path function that I wrote myself, and this one uses the Dijkstra algorithm, which basically means keep track of all the costs of traversing and always process the lowest node. So if you hit something that you've already visited, you move on, you skip it. This is basically the bounce checking. This is another check to see if the target where you want to go to wasn't visited yet. So if it's a new place, then we visit it. And if we end up at the end position, we return the new risk. So this is the value of how we got here, plus the move for the next statement. So if we run this one, we should get an answer in, yeah, look, 0.06 seconds. So that is pretty fast. 540. And that's the right answer. So let's do part 2. I'm just happy that this works. Let's see, now that you know how to find low risk paths in the cave, you can try to find your way out. The entire cave is actually 5 times larger in both dimensions than you thought. The area you originally scanned is just one tile in a 5 by 5 tile area that forms from the full map. Okay, so it's 25 times bigger. Well, it's fast now, so that shouldn't be an issue. I really wonder why they made the first part hard enough to not be able to do without Dijkstra, because usually what they do is that they have a part 1 that you can be a little bit naive about, and then the part 2 where the naive approach usually doesn't work. But okay, let's see. The area you originally scanned is just one tile in a 5 by 5 tile area that forms the full map. Your original map repeats to the right and downward. Each time the tile repeats to the right or downward, all of its risk levels are 1 higher than the tile immediately up or left it. Okay. However, risk levels above 9 wrap back around to 1. So if your original map had some position with a risk level of 8, then that same position on each of the 25 tiles would be as followed, blah blah blah. Each single digit above corresponds to the example position with the value of 8 on the top left tile. Okay? Because the full map is actually 5 times larger in both dimensions, that position appears a total of 25 times, 1 in each duplicate tile with the values above. Here's the full 5 times as large version of the first sample above. Okay. So this is the 1, so this is also 3, 4, 5. Okay, so it's basically steps. So the path will be huge, yeah. Even building out the full data set will be huge. Well, not huge, but big enough. Equipped with the full map, you can now find the path from the top left corner to the bottom right corner with the lowest total risk. Okay, the total risk of this path is 315. The starting position is still never entered, so that its risk is not counted. Using the full map, what is the lowest total risk of any path from the top left to the bottom right? Okay. So let's first build out the map, I guess. Let's copy my part 1 for now. And let's start with the actual values here. I think I'll just expand the columns first and then do the rows. Since they're already lists, they can be easily modified. So for each, actually no. Let's see, for int I is 0, I smaller than 5 plus I. I'm just thinking if it's easier to go by, yeah, I can just do for each var row in map. Right, then I do 5 times, let me see. Hey Sunco Software, welcome. Sorry about yesterday, I could not see the chat at all in YouTube Studio for some reason, so thank you for joining me. I wasn't ignoring you guys yesterday, I just really couldn't see any chats. So I pulled up a second screen just to be able to make sure that I catch it all. So, and the stream should be in 1080 today as well. Let me see. Yeah, it's in 1080, so I changed that as well. And somebody asked me to actually increase the font size. Let's just oblige with everything today. I can just make this a bit bigger and move this down and just have an increased font size so that it's easier to read. So yeah, this should be okay. Actually, I can do 1 smaller equal to, so this will be the addition, and now I can just do for each because it will grow once I start adding. Let's see, var values is row.to array for each. Come on, for each var val in values, and then I can do row.add val. I knew there's something different. Text was all broken up before. Yeah. Feel free to leave suggestions if something isn't right. But I used to stream to Twitch with Streamlabs OBS, and I switched to YouTube this year, and I used the classical OBS, so that yeah, that might be a bit. And it defaulted to 720p for export, so yeah, I just changed it to 1080 today. And I increased the zoom as well now, so it should be easier to read. Because usually the area of code where I work in isn't that big. So yeah, let me see. For each found values, you can just do int new val, and then you do new val is val plus I if new val larger than 9, new val minus 9, and then we do row.add new val. I think this should work, but I should probably print out the score for now. So this should be, let me do console.writeLine string.join, come on, string.join row. Right, this should dump out the test case for the first part. Doesn't look big enough. Let me check. Okay, it does want to make, oh yeah, because there are already 5. But basically the idea works. So I was wondering, is there a 9 somewhere? 9? Yes, of course there are 9 somewhere. Let's see the third one here. So that becomes a 1, 4, 7, then you get 5, 8, 2. Yeah, okay, so that's all correct. So let me just get the third line here. Okay, so the basic idea works. Okay. So this becomes smaller than 5 still, and let me just, since it's one base, I do smaller equal to 4 to be clearer about my intentions. So this pads out those rows, and now I just need to repeat the same in another direction. Let me see, values is row to array, so that is cool, that is the new row. And now we need to do list int new row is new blah. And this needs to be 5 now because we're copying down. Wait. No, the same thing is true. We need to do that 4 times, and this becomes new row. So let's run this. Oh, I need to add the new row. I could just copy it now. For each row and map. I need to I need to switch those. So that looks more like it. Let me see if I can find this as well. Okay. So that works. Let me test the last row here as well, because this looks like I need to add more. See, I'm missing. Let me see. Free throw to take, and I need to, at the end I need to make sure to add it, so I can do map.add new row. I wonder. I need to, my bad. In this case, I need to do int row offset is 0. No, that's not true. Let me think. Because it's shifted down, so that is fine. This needs to be 10. I'm an idiot, sorry. I don't know why I wrote... yeah. No, I took 5 instead of 10. So now I have them all. I was just being an idiot. Because I had the 5 repeating in my head, but the original size was smaller. Let's see. Int original row count is count, right? And now I can just do take original row count, and this should be fine. So now it should still spit out the last one. Right, boom. Okay, so that was expanding the map. Not sure if that's the most efficient, but hey, I calculate them once and then I don't have to think about them anymore. And now we do this. And I already have it set up to just be the map size. So part 2 should just be this now. Not good to hardcode to 10 either. Yeah, I don't have that. I already switched it out to be original row count here. Let's just run this. I think this should be it actually. 315. Okay. Oh yeah, this is the test input. I forgot about that. Yeah. So that works. It works on the test input. Let's switch them around and not print it out all the time. So that's a benefit if you like take the correct approach right away. Usually the part 2 isn't that bad. So 2879. Boom! Day 15 taken care of. Great. That's great. Glad that worked. So let's do day 16. And what I probably could do is have it, yeah, it doesn't really matter. This is fine. I could configure like the expansion part into a separate function so that you can take on dynamic growing, etc. But it's not needed. Let's move on to day 16. Packet Decoder. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. The transmission was sent using a buoyancy interchange transmission system, bits, a method of packing numeric expressions into binary sequence. Yay, binary! Let me see. Your submarine's computer has saved the transmission in hexadecimal, your puzzle input. The first step of decoding the message is to convert the hexadecimal representation into binary. Each character of hexadecimal corresponds to 4 bits of binary data. Day 16 was more my thing. I enjoyed this. Okay. Yeah, I liked yesterday, but when you don't know how to code the algorithm, it's a challenge, right? So once I figured out how that worked, yeah, it was okay. I had fun writing the first version that didn't work, but It gets frustrating really quick when you can't move on. Let's see. The first step is decoding, blah, blah. Each character of hexadecimal corresponds to 4 bits in binary data. Yeah. The bits transmission contains a single packet at its outmost layer, which itself contains many other packets. Okay. The hexadecimal representation of this packet might encode a few extra 0 bits at the end. These are not part of the transmission and should be ignored for now, right? Every packet begins with a standard header. The first 3 bits encode the packet version, the next 3 bits encode the packet type ID. These 2 values are numbers. All numbers encoded in any packet are represented as binary with the most significant bit first. For example, a version encoded as the binary sequence 100 represents the number 4. Yeah. Packets with type ID 4 represent a literal value. Literal value packets encode a single binary number. To do this, the binary number is padded with leading zeros until its length is a multiple of 4 bits. And then it's broken into groups of 4 bits. Each group is prefixed by a 1 bit, except the last group, which is prefixed by a 0 bit. Okay, I need to read that later to understand it. These groups of 5 bits immediately follow the packet header. For example, the hexadecimal string this becomes this. Okay. Below each bit is a label indicating its purpose. The 3 bits labeled V are the packet version 6. Okay, let me just start preparing something because this will take some doing. Let's stop running. Date 16. Date 16. Let's clean this up. Just remove everything. Actually, I can just delete the whole file like this. And just copy this and make it part 2. Okay. Program should run date 16 now. And let's go back. Okay. So let's move this over. Version bits is 3. Packet type ID is 3. Okay. The 5 bits labeled A start with the 1, not the last group. Keep reading. Ah, okay. Okay, that is fine. B, start with the 1, not the last group, keep reading. 5 bits labeled C, start with a 0, end of packet. Okay, and this contains the last 4 bits, the number 0, 1, 0, 1. The 3 unlabeled 0 bits at the end are due to the hexadecimal representation and should be ignored. Okay, so this is just padding out because I assume this one is not divisible by 4. Okay, let's see. 3, 6, 11, 15. Yeah, okay, that's 1 over, so you leave 3 padding. Okay. Bits per segment is 4. Actually, it's we pad out to that. Okay. So this is very doable so far. So this packet represents a literal value with binary representation. So you strip off all the, so this should be 0, 1, 1, 1, then 1, 1, 1, 0, then 0, 1, 1. Okay, yeah. So you strip off the first bit. So this is all still very doable. Every other type of packet, any type with a type ID other than 4 represents an operator. Okay, let's get back. Public enum message type literal is 4. Okay. Every other type of packet represents an operator that performs some calculation on one or more sub-packets contained within. Right now, the specific operations aren't important. Focus on parsing the hierarchy of sub-packets. Okay. An operator packet contains one or more packets. To indicate which subsequence binary data represents its sub-packets, I need to remove the marking if it won't quit. And that's Creative Cloud that keeps telling me it's updating, so sorry for all the noises. Let's see. An operator packet can use one of two modes indicated by the bit immediately after the packet header. This is called the length type ID. If the length type ID is, okay, let's code that up as well. Public enum sub packet length type ID, length type actually. This will be whoa. If it's 0, then then the next 15 bits are a number that represents the total length in bits of the sub packets contained by this packet. Okay. Okay. So we have sub packet length is 0. Next 15 bits are sub packet length. So those are 3 groupings of the 5 bits again for a 12-bit number. Let's see, and then we have type ID 1, then the next 11 bits are a number that represents the number of sub packets. Number of sub packets is 1. Next 11 bits is number of sub packets. Then I wonder why this is okay, it's because it's padded out by a 0, right? Because it would only need 10 bits to tell us a 8-bit number. The first one will start with a 1, then the second one will start with a 0, total of 10 bits, but this one is also 1 bit, adding another padded 0 to come to 12, which is divisible by 4. Okay. Finally, after the length type ID bit and the 15-bit or 11-bit field, the sub-packets appear. For example, here is an operator packet, hexadecimal string blah, with length type ID 0 that contains 2 sub-packets. Okay. Let's see. This is the length of the packet in bits, is 27. First sub-packet, literal value representing the number 10. Second sub-value, literal value. Okay, but this can repeat, right? I'm sure there can be nesting. A. So let's see A. So that's 110, that's a normal packet header, right? Yeah, packet version 6. Then we have 100, which is packet ID type 4. Okay, this is fine. Okay, so you just read the packet, because this can be variable in length, but parsing the packet will tell you how far it goes. So this is fine. So that lets you read the packets. Okay. After reading 3 complete sub-packets, the number of sub-packets indicated in L is reached. Wait, what? Oh, that was the second example, sorry, here. So here it will tell you that there are packet type Okay, so we have a 6. So anything else is operator. Let's see, the bit labeled I is the length type ID. Yeah. Let's see. That was 3 subpackets. Boom. After reaching the 3 complete subpackets, the number of subpackets indicated is reached, so parsing the packet stops. Okay. For now, parse the hierarchy of packets throughout the transmission and add up all of the version numbers. Okay. Here are more examples of hexacoded transmissions. Version 4, version 1, version 5, version 6. Okay. Okay, this sounds very much doable. So let's write a parser. And let's start with an example, of course. I should probably take one of the okay. Let's just take these examples and make sure that they all work. So let's say const string example A is this, const string example B is this. Actually, I can do better than that. Let's do dictionary string int tests is new blah. And let's just write something that works for all cases. Yeah, this is a fun one. I like this. Actually, I can just use these ones because these have actual answers in them. Let's see, this one is 31. This one is 16, and the one in between is 12. Okay. Okay. So let's write that out. I could just do this, right? And I have my own mapping. Let's see, dictionary char string I wonder if I should do this or just use all the built-in stuff, but it's kind of fun to am I really gonna do this? Because this is a lot of copy pasting. It's probably faster to just to just write them out, but I think it's kind of fun to just have a lookup. And a lookup might be faster than doing the well, actually, I think the native code might also just do lookups. So. I need to do toChar right here. toChar array. Boom. Why is it complaining? Okay, let me cut this for now. Ah, I know what I did. Haha. The first one is not a string. It's not a char. I need to specify this as a char. Right, okay, so now we have a lookup. So let's see, how do we parse this? We have a message. String hex. Okay. String builder. SB is new string builder. Hex times 4 for the length. We do for each char c in hex. SB.append. No, not this per hex. I have the same name here. Hex lookup. Alright. Hex times 4, and we append hex lookup c. So this is our new string. So then we have a public string raw bits get set, and we can do raw bits. Raw bits is SB to string. Hex.length. Okay. So now we have our string bits and we can parse them. It's very inefficient to store it this way probably, but it's easy to read the bits like this actually. Yeah, because if you get into the really large numbers, you need to parse them anyways. So let's see how far I come with this. So let's also int start index to tell where we need to start parsing. Okay, let's see. Public int. How did I call it? It was a version number, right? Message type and version number. Packet version. Public int packet version. Yeah, so this should probably be a byte because it can never be really big, but who cares? I wonder if I should. Okay, it doesn't matter. We have the packet version, public byte. The second one was called packet type. Packet type. Let's see, and then we have. Oh, this was for the literal version, right? Let's see, that was the. Okay, yeah. Okay. Now we need to start processing this. String var is raw bits, that's substring start index let's do this. Int ex is start index. Start index. Let me think. Because I can't do this yet. So this will be too big, but it doesn't matter. Let me see. Yeah, this whole raw thing doesn't matter because you need to parse bit by bit. For int I is start index, I smaller, hex.length, I plus plus. Or actually no, we need to first get those two and know how to proceed. At what point do we mention that toInt32 has a base parameter? Yes, I know. But just let me struggle for a bit, I love this. Let me see. We first do hex.substring start index 3. So this will be the version. Packet version is where is this? And I actually want to do it like for int I is 0, I smaller than version bits plus plus I. And then we do if var I is 1. Let's see, packet version is 0. All right. Then we do packet version plus is 1 offset by version bits minus I. Version bits. Let me see. Are you building a fishing game today? No. I'm doing Advent of Code today. Welcome, Anders. Anders just had a stream with Millions on Mars, a project on Wax, so it's nice of you to come hang out a bit. I'm doing a programming challenge, a packet decoder. So this is a binary format that we have to decode the messages for, and there are 3 ways of parsing it. I'm just doing it the hardest way I know, because I kind of like that. Let's see. So if the bit is a 1, we do minus right, let me think. Yeah, and this can be cast to a byte because it's not that problematic. So if I is 0, that means it's the third number, and we need to shift it by 2 to get it in a proper representation. So this is fine. Yeah, I think this is the one. So this will build up the number, and I need to test this to make sure, but this should be good. Let me just test it to be sure. So let's do this and do var m is new message. So we have 0, 0, 0, 1, 1, 1, 1, etc. Well, let's just complete them all, right? Console.writeLine. m.version. So let's just print out these versions, and this should be incremental numbers if I did my bit shifting correct. Or throw errors, you know. 0, 1, 2, 3, 4, 5, 6, 7. Okay, boo, it works. Right? Besides me not writing right line. So what we basically written now is something that can take a variable number of bits and build a number from that. So let's just write that as a function. So we do byte decode string hex no string, this should be the binary string binary string binary, and then int start index int length. Okay. And I pass in binary here, which should have been hex, so I need to fix that as well. Result, come on, result. Let's do byte result is 0. Okay, so this is the bit shifting stuff. So now I can say packet version is decode for 0, 3, right? And I should probably do it like this. But this also needs to be decoded first. So yeah. Let me see. I'm just wondering if I need to decode the message in here. I'm doing so many things in my head that I need to slow down a bit. So what I can do is var binary. No, we can't do that because we need to decode the message. Let's just do it like this. Binary. I think this makes more sense. And we do start index binary. We can remove this. And why do I do this? Because you need to decode and move along blocks anyway. So I just need to move this back here. I'll get there. Let's just make this work first. So we have packet version is decode this. Let's run the code again to make sure that it still works after all my changing of stuff. So I have 0 to 7, which is great. So that is my first test here, and I can remove this. So next there will be 3 bytes for the operator, right? So we need to do that as well. And what we need to do is actually move the index along for the length that we get. So what I might have to do is have a int read index. And have a function that says string read int amount and then I do the raw bits here. And then you do raw bits dot substring read index comma amount. And then we do read index plus equals amount, return result. This way we can have a pointer to where we are reading and move the whole thing forward. So I can do an overload here. Like this. And this will be decode read length. Right. And we can do read index is start index. So now we have that set up as well. Dun, 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 dun. So this will move our pointer forward so that we can keep track of where we're reading and when we need to stop, etc. You are listening to one of my favorite royalty-free music. Yeah, it's Harris Heller, Renegade. So yeah, it's Stream Beats. The guy is making a fortune off of that. It's so funny. He has like this whole streaming career on Twitch, trying to do everything, and then he did videos on YouTube about how to grow as a streamer and what to do and camera gear and all sorts of stuff. And he did everything fairly successful, but when he created Stream Beats to solve a problem with the music that you play during streaming, which is a stuff that I can talk about for a long time, that just blew up so massively for him that he's just making bank. He can basically already retire off of that, but he just keep expanding it. And that's something that you see a lot, like for companies. They work really hard and are really good at something, and then they get lucky with something and pivot to blow up completely in a direction that you didn't expect. So yeah, I'm building a whole message parser here, and I'm having fun. But let's see. Packet version is this, and then okay. Let's see, packet version, and then we had the packet type, which is the same. Actually, it's message type, right? Okay, well, it's packet, message, I mixed them up. So I could call this a message type here, and this will try to match that. I should probably do like other. Because there are actually any number of values. Let me just change that back for now, because we don't know all the values. So we'll just do packets type there, and we do if packet type equals to byte message type dot literal else, right? So if it's a literal, we process that in a different way than all the other bytes. Let's just make this readable from the outside so that any next parser can go on with that. So we have that. So for the literal 15-bit number, let's see. 6 was operator. Wait, let me go back. Version 1, packet type ID 6, which means packet is an operator. No, we didn't. There are so many of these examples here. Let's see. 4, which means it's a literal. Okay. After that, you always get numbers. So it's a variable length, right? And then it should be padded out. Okay, so let's see if it's a literal. Let's do decode. No, actually we do read 5. So let's do const int dynamic number length, dynamic number packet bit length. 5. Const byte, const car, last segment is 0. So we can do that as well. So we do string segment is, and then we do while segment 0 not equal to last segment. Right, so this will keep reading it. And then we also need to make sure that we pad them out. Let's see, list char number bits is new. Boom. I wonder if there will be very large numbers, but for now this should be okay. So I can do number bits. Number bits that add range, and then I do segment dot skip 1 to try this. And I do that once more here, and in here I do this. And now I go for, let's do int number length is number bits dot count. I also need to make sure that I pad out that. So I need to do int rest is number length divided by 4. 4 minus this. Percent 4. If rest larger than 0, read null bytes. We do read rest. String empty is if empty not equal to new string 0, rest throw new application exception should not be non-zero. Let's see, it's calming to listen to you while you code, by the way. Nice. I'm glad I'm putting you to sleep. Nah, just kidding. It's so nice for you to hang out here. Dun, 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 dun. Now I'm off to spend some time with the missus. Enjoy creating your bit unpacking fishing game. Yeah. Thanks, Anders. It was nice of you to keep me company for a bit, a hangout. Hope to see you again soon. So let's see. So this reads out the padding for the null values. But we need to read them to make sure that we do the processing correctly, and they need to be 0. If not, there's something wrong. So we have that. And now we need to do for int I is 0, I smaller than... actually, we can decode this. Decode number bits string dot join. Let's just support this as well. Come on. Char array. Come on. All the typos. Okay. So this can be decode binary to array. Boom. I have all the overloads ready. Why is it complaining? Okay. Bum, bum, bum. So now we can have decode int val is this, and let me see. So we can have public long numeric value get set private literal value. Let's just make sure I remove this, because this can get quite large if you have enough bits. So for now we support 64 bits. This needs to be a long as well. What's the problem here? To array. Okay. And we need to cause these to byte, because we know that the range is small enough to be supported in a byte. So now we can read this literal string. Let's test that. Var m is new message. Zero. Console.writeLine m.literal value. Let's see if this works. 3. That's not correct. Okay, let's step through that. Okay, let's see. So we have packet version 6. Packet type is 4. Packet type equals that, so that is good. Segment is read this. It's 100, right? It's not the last segment. So we add segment.range blah. Okay. Okay, so that is good, right? Okay, so if I do quick watch here, and I do a string.join this, that, and that matches, so that is good. Okay. Dun, dun, dun. The rest is 1. That is not correct. Let me see. Number length is 12. Divided by 4 is 3. Oh, but it's actually 5. Let me see. Yeah, by 3, and then you do that times 5 actually. So it's this times 5. Okay, my bad. Actually times dynamic number bit length, and this will be -1. I could probably just keep track of that, but yeah. Okay. Let me think. But if this is 6, and this is 15, it's 21. Yeah, okay. Let me think. Read index. We can also have public int raw start index. Yeah. So we do this is start index. And actually, to know if we are aligned, we should probably just get the read index minus a start index. So do read index minus start index percent 4. Do 4 minus this. Let me just do this again and run it to here. What's the problem? Rest is -1. Wait, what? 21 minus 0. 4 minus... I need to move this outside. Let me see. No. Just need to do it like this, and then if it's larger than 0, then you do 4 minus this. Okay. Let's see. And I hate magic numbers, so this is what we should do. Okay. Haha. Empty is 0, 0, 0. Okay. Okay, let's make sure that this is correctly. Set next statement. Okay, let's run it again. so rest worked. Okay, now we have these numbers. Ah, the length. That makes bum, bum, bum. This makes more sense now. And now we have 2021. Okay. Phew! So literal packet decoding works now after some debugging and testing, but I'm happy so far. Bum, ba-dum, bum, bum. So if it's not, let's see, packet type. We should probably do a switch case here. Switch case. Break. Default. Why is it screaming at me? Okay. Cool. This is a typical thing for a case statement because I assume more stuff will be added and then we can add it to the case here later. Okay. I probably need to watch part of that. Okay, so now it's operator. Let's see. 0 was a 15 and 1, okay. So now we read 1 byte. Read 1. And we do char operator, that's reserved, okay. Op is 0. Switch op case 0. Break 1. Default throw new not supported exception. We don't have support for type yet. Okay. I feel like I should move my camera here so that I don't keep typing, because I usually type in the more bottom part of the code of the screen so that I'm not covering the code up with my face. Okay. So let's see, we have this operator and then we have I'm just thinking. If I should parse this as a, or if I should just do 0 and 1 like this. I think you can do that. So I can do char dot subpacket length. Number of subpackets, right? Well, it doesn't matter. This works either way. I think you could specify the base type normally, but yeah. We have that mapped. Subpacket length. Dun, 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 dun. And this should actually be this part should actually be a function, I think. So let's do read dynamic number length number. Char segment. Okay, I can just do this. Dun, 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 dun. I can do return to array, right? So now here I can do read dynamic length number, and then we can get rid of all of this. Let's just comment it because I don't want to write it again in case something doesn't work. Let's run this again. Yeah, it still works. Okay. So now we can do int sub packet length. Packet's total length is this. Long, actually. It doesn't really need to be a long, but that is fine. Dun, 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 dun. And this is sub packet count. And now I could do, because it ends here. Let me see. This pads it out, so that's also fine. And then I can just call myself, which is dope AF. So now I can do for int I is 0, I smaller than sub packet count. And I can do new message, raw bits, read index. Man, this is cool. I really like it already. This I can just do here. Public list message sub messages. Let's initialize that as well. And I can do sub messages that add this var msg is this msg, and now I can do read index equals message.read index. So we forward our read index to read the sub packets. So even after, if they change something that we do it after, this will still work. And this actually also works. So what we can do here, I do end target end index is read index plus this. And we can do while read index smaller than this. Okay, long. And this should be able to parse everything. So let me see. For each var test in tests, string binary is test.key.select x dot boom, 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 boom. Can just do new string actually is new string. Okay, and then we do var message is new message binary 0. If message dot and then we need to okay. Let's see. What did we need to count up? The version? Versions, okay. So then we do public long version sum get, and we do long result is version number. No. Packet version. For each var sub message in sub messages, result plus equals sub message dot version sum. So this will recursively add it up, return result, no matter sorry. No matter how many levels deep, this will make sure that they all go down to the lowest level. And then we can do if message dot version sum test dot value console dot write line, come on, console expected got from blah test dot key. Sum is message with version sum test value. Okay. So let's see what happens if you run this. Cool, none of them work. That's great. That's too bad. Let me see. What happens if I let's see if I run this. Can I decode the sub messages? Let's see. We have the raw bits. It has 0 sub messages. That's sad. Okay. Let's fix this. Set next statement. Start index is 0. It's an operator. Okay, and the op is 1. Okay, sub packet count is 0. Okay. Let's see, read index is 12. Okay, that's not correct. Read dynamically length number. Okay. Okay. Let's debug that. Because this should read 15. So this reads 000. Wait, what? Ah, okay. So this just means read 15. Okay. I can work with that. Okay. I can work with that. I kind of want to add an attribute for how long the message should be, but let's not do that. I have them in constants here, I think, like 15. Oh no, it's not here. Okay. So let's do int number length get number length. Come on. Sub packet. Okay, switch sub case. Come on, case dot. Sub packet. Number of sub packets is 11. Case return 15. Default throw new not supported exception. Invalid length. S. Okay. Dun, 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 dun. Let's see. So in this case, we do read op, and I think we just do this instead. We cast it first. So let's see if this makes a difference. Boom. Where is this call stack? Wait, what? So now we're probably in a sub message. Let's see, call stack. Sub packet here. Okay. This was this test case, right? Let me see, raw bits. Let's see, number of sub packets. Okay. Okay, let me see. Oh wait. I wonder if I need to align it. Because this was already skewed. Let me see. So in this example, let me see. 7-3 operator. Number of sub-packets. 11 bits, right. Literal value containing the number 1. Yeah, we have that. Wait, why is it padded out here with more zeros? Let's see. 11-bit sake, literally string 3. And then there are 5 zeros after that. But we can stop reading there because it's done. I wonder why there's no padding for these numbers, right? Literal value representing the number 1. So that is strange to me. So you don't always have to pad out. Okay. Public bool is sub packet. Let's see, right? Bum, bum, bum. Those are 3 packets. Yes, I know, but they said before that when you process a literal, the numbers are padded out. So I expect that when you get a literal within the sub packet that you also pad it out. But and I pad it out to the message in this case, but is the stream okay? It says, let's see, 3 for version, 3 for time. Yes, I know. That's why I offset the start of the message, the packet. That's what I did with the padding here. The rest is read index minus raw start index. So it starts from the message start. So it takes those 6 into consideration here. Right? So this message started at index 18. Oh, let me see. Type 4 in this case, so you have to read 5 bits. Yeah, it does that. It did that. I can show you. Let me step through it here and I'll show you. But if you look at the example here, you can see that there is no padding for the sub messages with the literal. Because that's, let's see, 3, 3, the 6, 7, and 5, right? No, it's 11 bits, right? Dun, 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 dun. Yeah, I expect there to be padding actually, but let's see. I don't use the is sub packet now, but I want to use it as a flag to see if I need to pad it out. So here we've read, you have like the raw start index is 18. The current read index is now at 24. We read the two packets. We go into a literal and then it goes here like boom, that's not correct. Padding is only for the outer message. Yeah, that's why I was adding the is sub message here. So I'm doing that now. If not is sub packets. Let's see, version sum, get number length, blah, blah, blah. Okay. And now here we do true. Same here. And actually it needs to be let me see. Yeah, no, this is correct, is sub packet. So now it works. 14 for the first one. So let's do the tests. It does all the tests. Okay, so all the tests work. Great. That is nice. So I think we're ready to finally read the puzzle input. Okay, so do bum, 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 bum. So now we do m is new message. Dun, 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 dun. Let me just remove this for now. And this becomes input. Now we get part 1 sum. Kinda sad to see it end now. What happens here? Oh, there are money. Let me see. There are more lines in there. Let me see. Quick watch. 2 lines. No, lines. Come on. Okay. For each raw in input 2 lines. How many are in there? Just 1. Okay. Boom! 1 try. That was nice. I like this one a lot. I probably wrote way too much code for it, but I like the way that I did it. Yeah, you copied the new line. Yep. Okay, let's see. Now that you have the structure of your transmission decoded, you can calculate the value of the expression it represents. Literal values represent a single number as described above. The remaining type IDs are more interesting, so now we get into all the type IDs. So yeah. Just 1 input line. Yeah. I needed to trim it because the raw had a new line character in there. So now we have all the extra operators that we can put in here. Sum is 0. Product is 1. Minimum is 2, maximum 3, greater than is 5, less than is 6, and 7 are equal to is 7. Okay, cool. Let's see. Using these, I'll read this later. Using these rules, you can now work out the value of the outermost packet in your bits transmission. For example, find the sum of 1 and 2 resulting in the value 3. Find the product of blah 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 resulting in the value blah. Find the minimum. Okay. What do you get if you evaluate the expression represented by a hexadecimal? Okay. First, I want to see how many layers deep it goes. But because I didn't check that yet. So this is the message. So it has 53 sub-messages, okay. Do any of those have sub-messages? Yeah, those can also have sub-messages, okay. Cool. Shouldn't be a problem. What? Produces 1 because 1 plus 3 is 2 times 2? Okay, I need to read this to understand it. I think it should be fairly easy to implement because I set it up in the way that I did. But I don't understand how to do this yet. Let me see. Packets with type 0 are sum packets. Their value is the sum of the values of their sum packets. If they only have a single sub packet, their value is the value of the sub packet. Packets with type ID 1 are product packages. That packet is a result of multiplying together the packet. Okay, sure. Yeah, this should be fairly easy. So we just do this one again. Only this time we do it in the sum version sum. So public long part 2 get. And here we switch all the packet types. Let me just move this so that you guys can see. Yeah, this one is really fun. I'm having fun. I hope you guys are having a bit of fun as well. But yeah, I'm having a lot of fun with this one. Let's stop running. Let's hide this to get some more space on the screen. Move it a bit to the right. Okay. Packet type. Oh yeah, I should probably put that as an op, like this. No, this packet type. Sure. And I should probably cast this as a message type. Okay. I wonder what you do if it's a literal, you just return. What do you do with the sub packets when this one is a literal? Oh, then there are no sub packets, right? Return. Then you just return packet version. Case, let's see, sum. Let's start with sum. Dun, dun, dun. So basically this was already the sum, and I can also do just result here and return below. Yeah, return literal value, I already had that, thanks. Return result, and do result is this. Let's see. Packets with the type are sum packets. Their value is the sum of the values of the sum packets. Okay. So you no longer look at the packet version here. So you do 0, and then you do, it's not the packet version you need. Yeah, for literal there is. Ah, you're right, literal value. You're correct. You're right. Thanks, that saved me some debugging later. Let's see, we do result plus is part 2. So that is fine. Case dot product. If result is 0, result is submessage.part2. Else result times times is submessage.part2. Okay. That is product. Case, let's see, min max, okay, the minimum of their sub packets, okay, case, break. Link to the rescue. Okay. Maximum package value, maximum greater than. The value is 1 if the value of the first sub-packet is greater than the second sub-packet. Otherwise, the value is 0. These packets always have exactly 2 sub-packets. Okay. Okay. In this case was called max greater than. Okay. Greater than. Break. If submessages that count not equals to 2, throw new application exception. Message type that greater. Let's see, just message. Packet type in this case should always have exactly 2 sub packets. We have sub messages that count. Okay, so that is a validation. That is fine. That's the first one is bigger than the other, right? Greater than 1 if the value of the first sub packet is greater than the value of the second. Otherwise, it's 0. Okay, so we do if submessages 0.part2 larger than submessages 1.part2. Let's do we can do it like this. Result is 1, otherwise it's already 0. And that is fine. Less than, let's see, less than is the same. Do the same, but otherwise, and equals to, okay, same thing. Okay, so this should work recursively, so that is fine. So let's see. We have some more test cases to work out. I need to break here, break. Okay, so let's add some more test cases. Part 2 tests. Let's see, we have this one and we expect 3. $54. 7. 9. 15. Ah, damn it. 3, 54, 7, 9, and then it should give 1. So this one should give 1, then this one should be 0. Okay, 0, and then the last one will be 1. Okay. Call this part 2 tests. Some will be part 2. Okay, let's see if this works. And it works. That is dope. Nice. Let's do this part 2. Message at part 2. We can comment this away again. Negative number. Okay, that should not happen. Wait, what? Hmm. How can everything work, but all the test cases work, but then the big one, nope. There can be a negative number, right? So that it must overflow somewhere or something. How did this happen? Yeah, but I already use longs. I can make it a U long, but that means that I have to go into a bigger It's weird if it overflows. Uint instead of long. Why would I do uint instead of long? Uint is smaller than a long. That doesn't make any sense. Why doesn't it like this? I just use longs without issues, so I think you must have some ints left in there. Let me see, I have an error somewhere. Nope. Build errors. Let me see. It's not liking what I'm doing here. Okay, let's see. Yeah, I mean, in this case, these should all just be ints because there's no way that these indexes are so big. I mean, I can go up to 128 or 256-bit numbers if I have to, but yeah, okay. So it's an uint. Jesus. Didn't expect it to overflow. That's not right, your answer is too high. Huh. So that is nice, we have the full test suite working, but it doesn't work. So how is it possible that all of the tests work, do it like this. Let me see. Belong. I mean, all the tests work. What the? I don't understand. All the test examples that they gave me work. So where does it go wrong? Ah, wait. No, that's not it, because this one just takes all the small parts here. Wait a second. No, this also works for Ulongs. Pum, 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 pum. This might be. No, because all the cases are tested, they should work. So maybe this one isn't correct. So this is part one. Let's see. Let me see. Pum, 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 pum. Okay. Let me see. Console.writeLine. We can test that. Pom, 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 pom. New string. I can just do new string. Binary. Result. Binary. Oh, come on. Binary.length. Okay, let's see if I spit this out, what will it spam to me? So here's a 32-bit number. Let's make sure that I test that one. 36-bit number here. $40-bit, 36-bit. Okay, let's just make sure that I do convert to int64. I can do ulong.parse. Doesn't this one have a radix thing? From base, yeah. 2. So I can do new string binary ulong correct is if result not equals correct console.writeLine no writeLine expected blah got blah. Okay, would be a shame, but hey. Correct result. Let's set a breakpoint here and let's run this again. And let's hope that this is the issue. Nope, not the issue. F me. Okay, so all the literal parsing, everything is correct. Okay, that's annoying. What else can this be? Only thing that I can think of is this. But it makes sense that it's this and not something else. So, I don't know what to do now. Why do all my test cases work? Do all my test cases work? I want to check it now. Yeah, man. I mean, I coded it in here. It should. Yeah, I'm a bit stumped. My test cases work, but the end result isn't correct. I pasted this incorrectly, right? Like. Okay, let's check the subreddit, because I coded the solution. Can you scroll to the operations again? Sure. What do you want to see? Oh yeah, I wonder if the product one gets called, and that's also correct, right? Because yeah, all of these cases are tested here. This is probably like the literals, etc. Okay. But all these cases are tested and they work. So what in the is going on that this doesn't work for the total thing? So I think we ruled out a lot of stuff already, because the literals work, the big literals, and the test cases work, and I just don't know what else to try. So while I leave this on screen here, I'm going to check if the subreddit has something about let me see, I should probably check my input and maybe just post. I wonder if there's somebody that has an online decoder to see. Dun, dun, dun. Isn't there like a help thread normally? Dun, 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 dun. Okay, visualization. Okay, is that online? Live version. Okay, let me see if I wonder if this spits out the answer and to see what it does differently. Okay, this so they say this should be the answer, right? Well, it's not that I need another solution, it's that I coded something that apparently works for the test case, but not for the final input, and I have no idea why. You can post your input string if you want, and I can see what happens when I run that one. Okay, reconnect worked. Okay, let me see. I'm not sure that because the solution that I have is correct as far as I can tell. So reading another solution, don't think it would do much. I just wonder why this one ends up with a different. Can't paste in the chat. You can DM me on WhatsApp and I can open that. But yeah, oh man. Or create a gist file, or I'm just really annoyed that I came this far, and I think it's a pretty cool solution. I really like what I built. I could extend this. Okay. Dun, dun, dun. Let me see. Dun, 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 dun. Input is okay. So let's see what happens when I run. Okay. Const look is I can just do in here, just short circuit this. What's the error? Okay, Jesus. Let's just do bomb string raw. Okay. I thought I'd quickly add in this string and see how it worked, but okay, for you part 1 is 981 and then that one. Let me just see what you have in WhatsApp. I don't see the answers in WhatsApp. So for your input I get this. That's close to this number, but part 1 is correct, but part 2 isn't. Right, that's what you're saying, right? So part 2 isn't. I still get the same. Man, that's really annoying. I wonder if I should check each sublevel. Maybe you can do that as well. Let's just debug this. Let's see. For each var sub in message at sub messages. So I'll just keep your string for now and just dump out all the values here. Can you do the same? So let me open, let's see if we can debug this, right? Would be cool if I could find out which one of these isn't correct. I'm bust. What does that mean, bust? Ah, busy. Okay. Wait, what? I think I found an issue. No. Could it be that the top message isn't... Because packet type and packet version are not initialized here. Which is weird. Let me see. See, packet type and packet version are not set here. But why? Ah, they start with zeros. But that's not true, because here the raw... Ah, wait, no, it is true. Yeah, because that's the binary format. So the only thing I can think of is maybe that this multiplication here goes wrong. No, I can't think of what's wrong here. What I think I'll do is just throw this up in a gist and see and post it to the Reddit to see if somebody can figure out what's wrong here, because I don't know. Okay, let me see. Luke just sent me the file. Let me go back and compare. So let's see. I have... Okay. This one, in Luke's case, is 0. So that's interesting. And he has a lot more zeros, actually. Oh, wait. Do I not reset this to 0? No, wait. Because in this case, I reset it to 0, and otherwise I reset it to 1, and otherwise it should be 0. I wonder if it's... okay. At least this gives me something to step through. So, okay, cool. I'm glad that I can debug this still. Let me see, where am I? Here in submessage, okay. Let's figure this out. So the first one is an 8, that is correct. Then 3 is correct, then 20,000 something. And then it does this, and this is not correct. So let's step into... no. Set. Can I just go to 12? Okay. Okay, here. Message type is 1. Product. Okay, so there you have it. Ah, Jesus. The first one is a 0. Right? No, let me see. Yep. Ah. Okay, I got it. I thought that... okay. I'm just stupid because I know this isn't correct. For int I is 1, I smaller than submessages that count. Thanks, Luke. But I should have known this already, but damn, I'm an idiot. Okay. You need to print out those to make a good comparison of the output. Yeah, I already got it. I can tell you now that part 2 is this value, right? 299, etc. Can you confirm that this is correct? Yeah, the test is sometimes too simple. Well, they don't expect me doing stupid things. I can't really fault them for that. Oh man. So let's say string raw is 0. Haha. Man, I'm really glad that you could run that for me so that I could find my mistake. Finally, okay. But they should know you. Yeah. Oh man, it's always. I'm really happy that I'm done and that it worked. I'm just a bit disappointed that I had that stupid mistake. Yeah. So. Yeah. It's like a cool little machine that we built, and I thought, because at first when I read this, my mind immediately went back to 2019 with the encode computer that we built, and I had a lot of fun with that. And this kind of reminded me with like the operation. I was like, okay, let's make sure to build this out properly so that you can easily extend it to do more things, and that's exactly what we did. So part 2 was easy if I didn't have that bug. So yeah, did you do the encode machine? If you haven't, it's really fun. At least I thought it was fun. It's a bit of a love-hate relationship for most people, but yeah, the encode computer was really, of VM that you wrote, was really cool to do. So if you haven't done that, I would suggest you go back to 2019's event, and I'm up to day 7. Okay, yeah, I did all of 2019, I think. There was one that I didn't do. Let me see. For most years, there's like one that I didn't do that I still need to go back. So yeah, so I didn't do day 18, the many worlds interpretation. I can probably write that now though, but... And then it means you can't do the last part as well. Let's see, I have to refactor to allow for multiple computers and inputs. Ah, yeah. I don't even know if or where I even have that code, but it was fun to do. A lot of fun. I want to go back and complete all the other ones. I recently did 2 or 3 more days with Luc. No, I did day 21 and day 22 with Luc, which was fun to code up. But yeah, I will try to go back and do some more of those. But yeah, I really like the encode computer from 2019, so I'm really curious to see if our packet decoder gets more use later on. But actually, I think from the full description now, this has gone as far as it will go, I think. But I really like the way the code for today looks. Okay, can you share the link again without it being a link? Because you can't paste links still. GitHub.com. Ah, I still have it. Ah, it's for Simon Brooks. Okay. So I can just call you Simon from now, right? Let's see. Repositories. There will be an advent of code. Okay. If you get to 50 this year, I'll buy you an AOC t-shirt. Ah, thanks. I'll try. Let's see, where is... solve problem. Okay, let's go there. Ah, okay, I need to go to solutions. Okay. Let's see. As binary from hex. Is that an extension method that you made? Ah, okay. Good night, everyone. Yeah, thanks, Luke. I'll check this code out for a bit, and thanks for sending me your output so that I can debug mine. That was really appreciated. So these are the sub packets here, right? I like that we can do new like this now. I still need to install the new version of .NET. Parse packets, let's see, parse packets. Bit index is 0. Yeah, that's something I didn't do actually, to substring the raw packet, or at least cut it up for the sub packets. I could have done that too, but I just kept the read pointer there. Int from binary, bits index was 3, yep. I increment and, okay. Hey, the spread operator. Since when is this imported in, when was this added? Is that also .NET 6? That's nice. Let's see, packet operation type. Yeah. .NET 5, I think. Ah, okay. I've switched over to Core a while ago because it's just easier to deploy to my Linux servers as well. Let's see, length of the... Yeah, that's probably not very entertaining for people. I'm just reading the code and trying to understand it all and see how you've done it. I see heavy use of the spread operator to get chunks of the array out. So that's nice. Our number in this case is a string. Okay, so you can form a new string from the array here. Let's see, transmission. Ah, okay, so you can use a spread operator to do a substring here. Range, yeah. So this is basically a substring. Okay. Literal packets. In global, like it in flow, it resembles the stuff that I did a lot. Oh, you decremented here, okay. I assume, let's see, you have a nutrient length larger than 0. Wait, what? String new transmission is transmission. Ah, restaurant. Okay, where does this come from? Ah, that okay. So the parsing that takes out the packet and leaves you the rest. Okay, that makes sense. Okay. It's index. Okay. Ah, this looks nice and neatly packed. So you have the min max. Ah, okay. So use that to get a function there, okay? Yeah, this is nice and neatly packed here. So this makes it pretty readable. Public override long value type switch. Ah, this is the new pattern matching thing, right? I'm still getting used to this syntax here. Wait, public override long value type switch. Yeah, this still looks a bit strange for me, this first part. I have not gotten used to the new syntax and way of writing it yet. But I like how this basically becomes a small switch statement with like the arrow operators. It's really less verbose than all the stuff. You don't need to do breaks and like compare that to this part. I need to zoom out to get it on screen, but there's just so much white space and unneeded bloat here that I really like that they changed that up in the new .NET version. So yeah, nice. I should switch over to the new version sometime soon and get to play with all the new candy. Let's see, switch expressions are one of my favorite features from the latest release. Yeah, I really like the new accolade, because what I started to do is just always use var as the first. When I would normally write this as var numbits is new list, just to not duplicate the types twice, because it adds nothing. But now you can do this in the new syntax. But yeah, that's one of my favorites actually. I prefer making stuff readable, and the less noise you have in your code, the easier it becomes to read. That's why I like this. It's just a simple mapping between this and this. And it would be even cooler if you could like remove the operation dot. So if you could just write switch type of operation and then do dot sum arrow and then have your result, because repeating this operation here also adds nothing to the code except more bloat. So if you switch a type, it would be cool if they could just like do switch and have this in this qualifier here. I think that would be really nice to even remove all the duplicate stuff that you don't need. But yeah, I like it. Whew, I'm curious to see what they, let's see, I could probably add it as a static using. Yeah, but you would still have to have an alias for it then, right? Well, if you find out a way to make it even nicer, let me know. But I think I'll end it for here. It was a long stream, nearly 2 hours and 45 minutes again. So it's getting late. But I want to thank you for hanging out and staying with me on this journey. How long did it take you today? Because I feel it always takes me longer than I should have. I'll take a look. Okay, cool. So yeah, let's say goodbye and hopefully see you again tomorrow as we try day 17. Bye bye.